Hello, everybody. We're working on the Unit 6 programming exercises here today, and we're going to be going through three of them. And I do have the document that explains what each one is open here. So let's just read through the first exercise. So we're doing exercise 6.1 first, and it says, write a program that initializes a list with 10 random integers, then prints 4 lines of output containing every element at an even index, every even element, which is different, all the elements in reverse order, and only the first and last element. So these are, some kind of basic mechanical uh, tasks for working with lists. So this will be a good intro to that. All right. So what I did is I did copy the instructions and I'm going to paste them into my code here. So I'm going to jump over to Spider. Let's get rid of all this stuff in between here. And I'll just paste my instructions in there. I'm going to zoom in. And I think that's pretty good there. I'll zoom in on the console a little bit too to make it a little bit more readable. And then we'll begin by first talking about this random number thing, because I know that I had a extra credit assignment on this, and I did have a little like lecture material provided on random number generators and how to do that. One thing that we often do in programming is, especially when we try to simulate real world situations where we don't know what the inputs are going to be, right? Is we run tools that randomize information so that we can kind of simulate things. Like, for example, like if you were going to simulate like a casino game that had dice rolls, right? You'd have to be able to generate two random numbers between 1 and 6, right? That would be a thing you have to do to simulate it, right? Because in principle, at least the dice roll is random and it's not something that you can ever predict. The reason that we're having it having a random number generated do it, because if we ask the user to do it, they're more apt to put in something that's predictable, right? So to utilize a random number generator, there is a library built into Python that does that. And so what I'm going to do is I'm going to give you that command. I am going to drop it into the chat so you don't have to mistype it. So there it is in the chat, and then here it is in my code. And there is a whole random library, and it generates more than just random numbers, but we're going to focus on the random integer generator. So from the random library, we're importing the integer randomizer, basically. All right. The other thing that I did, and I'm looking at like, how many values do we want to use here, right? Now we're told up above in the instructions, it says to use 10 random integers to do this. But what I'm going to demonstrate is I'm going to set a variable that's going to hold the number 10 initially, and then later I can ramp it up to show you that it's really easy to change the scale of this if you wish. So I'm just going to come up with a variable called num int. Oops, I thought I was typing in there. Okay, num int. So basically standing for the number of integers that I'm going to process. I'm just going to put the number 10 in there. And yes, I could hard code that. But for right now, I want it as a variable because that way later I can change it and I just have to change one number and don't have to go in and tweak all the number 10s I put into my code. So that's the why I'm doing it. All right. Next thing I'm going to do is I'm going to create, and I'm just going to say this here, create an empty list that will hold the values generated randomly. Right. So the random number generator will generate them. And then as it's doing that work, I'm going to put them into my list. My list is going to be called values. And then I'm just going to give it a name and an empty set of square brackets. And that's all we need to do. So now I have an empty list. Just that simple. There's nothing inside of it. All right. I know that we haven't played with this stuff a lot, but like one thing that we do basically, like if I want to add a value to the list, I can do like really simple stuff like values dot append with parentheses. And then if I want to throw like the number one into the list, I just run that code and then I can print out my list and notice I can just print values. You can do that, right? And so I'm just going to run this just to show you, right? And notice what it did. It took the value one, put it in the list, and then I asked it to print the values. And notice how it printed it, kind of like a list, right? I didn't tell it to format it in any certain way. It put square brackets around it. And if I had multiple things in there, like for example, if I added another value here like that, right? And then I ran this code. Now it's going to output 1, 2, and my list is growing. And yeah, I could run this command again. And then the next thing I could put in is, text, right? And run it again. And it just works, right? Just an example of how you put stuff in. I'm going to get rid of that for now, but just, if you want to play with it and see how it works, there you go. It's pretty simple to do. And then you can always look inside of a data structure by just taking the data structure name, throwing it in the print command and running it, right? And then you can see the output of it. Well, for right now, we still need to do the random number generation. And I'm going to do that, think about this, right? This is going to be a repeating process. So that calls for a loop. I'm going to say use a loop because it's repetitive. I hope I spelled that right. Whatever. Okay, let's just move on. All right, so I'm going to set up a for loop to do this. I'm going to run a range command. And what's my range? Well, I'm going to start at 0 because I don't have anything in the list yet. And then I'm going to go up to the number of integers that I want, right? So I'm going to say for I in range, and here's the parens, from 0 to the number of integers that I've declared above, then I'm going to do the following. Now, this is kind of weird, right? Like, first we have to kind of learn how the random number generator works. And we're using, this is kind of a weird thing to do, but we're basically going to traverse the list. And why do I use the letter I? The I is kind of representative in computer coding of an index. So what this is really saying is that for the index values starting at 0 and going up to the number of integer, this is going to automatically increment. I don't know what that is by looking at this directly. I have to look up here so I can change that number at any time so it'll automatically adapt. All right, but before we generate random integers, we have to learn how that tool works as well. And if you did the lecture stuff on there, you kind of know already. But here's kind of like, and I'm going to do this in the form of a comment. So this is going to be non-executing code for now. I just basically call rand int. It's a function in the random number library. And then one of the things I can do with it is declare a starting value and an ending value like this. And when I run that, it'll randomly generate a number between 0 and 100. If I wanted to simulate a dice roll, what would I put in here? How about 1 through 6, right? That would make sense. So I would generate a random number between 1 and 6, right? It just depends on what I'm trying to do. So I'm going to use that code there in my for loop. So I'm just going to copy it or cut it actually and get rid of it. And then inside the loop here, I want the random number generator to run and then append that value to the end of my list. So I'm going to call values as a list. I got to type it right, values. And then I'm going to say append, right, parentheses. And then inside those parentheses, we'll put the random number generator, just that simple. It'll generate the random number and add it to the end of the list. So that'll do the work. And then, you know what, we have to see if it worked, and so what I always tell people is when you're playing with loops and data structures, um, you can do test prints. So this is what I often do, test print to see what happened. And so, all right, and I'm just copying the code I had last time, right? So this has to come back to the margin, and I'm just calling it test prints, just so we know that it's a test. And I already demonstrated the one approach, right? You just take values and put it in parentheses, and then it'll show you. All right, so let's just run this. It'll pull in the library, set a value to 10, create an empty list, rifle through this 10 times, create random number list between 0 and 100, and then we're going to look at it. All right, so there it goes. See how fast that was? It was like faster than a blink of an eye. It's already done. And are the values random? Yeah, they look pretty random. I have a pretty good smattering of numbers between 0 and 100. And how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values. All right. Remember, we started at 0, and the 10, we never reach it, right? The range, how the range command works. But we did create 10 values here. And so it'd be very easy then to change that to 100 values or 1,000 values or whatever, right? But it does work. We can output this in a number of different ways, right? And I'm just going to kind of demonstrate a couple of other approaches. You guys do not have to copy this, by the way. This is just testing, right? And so I can use like the what we call the argument approach, right? Where I just say the original values and then throw the variable in and it'll append it. Or I can use the F string approach as I do here. So there's the F and then just insert it. Any of those approaches work, by the way. Notice when I ran it again, different random numbers. And then you can intermix it with text when you're putting it on the screen, but it still displays the square bracket, so it shows the data structure as we're displaying it. But we're looking at the whole thing, right? So these are all what I call test prints. All right. Down here, I'm going to kind of create a bunch of blank lines just so we have a little space to do some more coding. Now we have a list of tasks to complete, right? So we got this going. And so really, I don't need to look at this, but why this is useful is that way I can see what's in my list. So then when I run the other commands, I can verify that they're correct. Otherwise, how do I know? You see the thinking on that? So, all right. All right. Now we need output that shows every element at an even index position. And I could write these as functions, but I'm just going to write this as straight code. I'm just going to tell you that right now. Later on, we'll put things into functions, and then we'll get a main method going too. All right, so let's display every element at an even index. So for example, if I look at these numbers here, this is position 0. Is that an even number? You should be nodding yes, right? So what we're trying to do is get it to print position 0, position 2, position 4, position 6, position 8. Right? That's our goal. So what I'm going to do is I'm going to start with a print statement. And what I'm going to do is I'm going to use this weird version of the print statement, and I want to talk about this. I think we've used this maybe once before. But when I do the print statement, normally it prints something, and then the next thing that follows prints on the next line. What if I wanted to print on the same line? This is what I'm doing here. By adding this command, so notice I close my string, I do a comma, and then put the end command. What this will do is it'll keep my cursor at the end of the print statement, so the next thing that prints right after it. So I can just say elements at an even index position, and it'll just list the numbers all on the same line, right? So that has to happen with the first statement that we print, and then I'm going to run a loop to do the rest, right? And so once again, loops are your friend when you're traversing data structures, right? So I'm going to say for I in range. And then can I just use the range command to do every other index position? I want you to think about that for a second. Sure, I can do that. If I start at position 0, and then I go up to position 10, which is number of int, it'll never reach it, right? So it'll only go up to position 9, but that's appropriate for a list of size 10. And then if I count by twos, right? So go from 0 to 10, start at position 0, count up by 2 instead of by 1, and then it'll just give me everything in those positions. I don't have to do any like modulus or anything weird like that. Although you could do it that way too, I suppose. So what I'm going to do now is I'm just going to output what's there. So I'm going to output the values in position I, which is where the counter currently is. That'll start at 0. The next time through it'll go to 2. The next time through it'll go to 4, etc. Because it's counting by twos. Right? So it'll print those values. But at the same time, I want to keep the output on the same line. So I'm going to borrow that end snippet from here and add it to my print statement, but I'm going to put a space in between. So when it puts it on the screen, it also puts space between the numbers. So it'll, say like 12, 80, 51, 23, whatever, but with spaces in between. And then what I do normally when I do these kind of exercises is I add a print statement at the end just to give us a blank line before we do the next thing, because we're going to do a few things here. So let's run this. And I'm actually, I don't know, I'm going to choose one of these here. I'm going to comment out many of my lines of code. And so I think I'm just going to use this one, the F string approach. So it's going to say the original list of values, and it's going to give me a list, right? And hopefully I can see them all at once. And then it's going to give me this message and then take all the stuff from the list and give me the right numbers, hopefully. So let's run it and see if it works. All right. So the original list of values, 36, 43, 86, etc. Position 0, got it. Position 2, got it. Position 4, right, etc. And it worked just fine. You guys all okay? Maybe. Okay. So far, so good. All right. Next command is display only even, let's see, every even numbered element, right? So that's what we want to do. So where did I had the instruction. Okay. Here's my comment. Only even numbers in the list. Okay. Once again, creating a bunch of blank lines here. Now you can imagine that we'll kind of do a lot of the same that we did. So I'm going to copy this statement to start with, just a print statement. And I'm going to say elements that are even numbers. That's a different thing, right? So, all right, that's just going to be a print statement. But now I got to do the calculations. I can't use the range command to do this, right? So I have to just run a regular for loop. And I am going to say again, for I in range, and then I'm going to start at position 0, and I'm going to go up to the number of integers that I have. And let's add a colon here at the end. And now, if you guys remember, how do we determine if a number is even or odd? All right, this is where modulus comes into play, right? So I can say if whatever value is in the current position we're processing, start at 0, go to 1, go to 2, etc. If I take that value and I mod it by 2, and that's equivalent to 0, there's no remainder, then I know it's even. And under that circumstance, I can print the current value. And I'm just going to borrow this print statement from up here and put it right there. So If it doesn't have a remainder when being modded by 2, print it. If it does, don't. So there's no else to that statement. And then once again, here at the bottom, I'm going to come back to the margin and I'm going to do a blank print command just so we have a separator. All right, let's run this one. We're going to get a new set of random numbers, right? And then notice from this new list, which ones are even? 4, 2, 46, and 18. 4, 2, 46, and 18. All right. The next directives is a kind of a weird one. And it says, display all the elements in reverse order. Okay. This should be a little bit weird. I am going to copy the print statement again and alter its text. And so I'm going to say, display in reverse order. That should be enough there, right? We're still going to use a for loop, right? And we're still going to use a range command. So that part's going to be repeated. And then let's do some parentheses. Now we just have to craft, this range command in a way that's going to make sense. Now I want you to think about this. We have a list of size 10, right? I have number of ints hard coded. Is it possible to run a range command backwards counting down? Yes, it is, right? So I can start at the number of integers, which is 10. But what is the highest index position number? 9. So I have to say num of int minus 1. That'll give me position 9 because that's where I want to start. Okay. Then I want to count down. Well, I want to go from 9 to 0. But the range command works backwards the same way it does forwards. I have to go one position beyond 0 backwards to reach 0, which would be minus 1. So I'm going from 9 to minus 1, one past where I want to end up, right? And then I'm also counting down, so I do another minus 1. So every time I go through it, I'm counting down. So that's the syntax for counting down through my list. Then ultimately, I'm just going to do the same print command again. So every time I go through, I'll start at position 9, go to position 8, etc., and just output the value. And then once again, back to the margin for a blank print command, just for formatting. Right. Now, the other reason we do this too, think about this. If I don't do this, this command still holds, and the next thing that's printed is on the same line. That's the other reason to do it. So if you hit run on this, all right, here's the original list, and here's the list backwards: 9, 32, 5, yada, 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 38. Yeah, that's right. All right. We have another directive, which is to display the first and last element. And we can do these in a number of different ways. So I'm going to demonstrate the first, I'm going to demonstrate, I guess, 3 different approaches for doing this, with the last one being the way I recommend, by the way. But I wanted to show you the other approaches so you can kind of like logic through it and why it works. So I am going to dump these on the screen one at a time and talk through it. So one approach is to do this, right? So I just grab the first position. That's going to give me the first one. Easy, easy peasy. And in fact, the first position will always be this for all 3 approaches I take, right? The last position, I'm going to the number of integers minus 1, kind of the same way I did up here. What index position does that give me? 9, right? And that works because I know the number that are in there. If I didn't, I could not use this approach, right? Here's another way to do it. This one is similar, but this one would work if I did not know the length of my list, right? So if I don't know how many integers are in there, I can run the length function, determine the length, which will be one higher than the highest index position, and then subtract one from it. So if it was 100, it would drop to 99. Or if it was 101, it would drop to 100, that kind of thing. So this one would work too. But then ultimately, the one I think is easiest, and this is the one that we saw in the Kahoot, mind you, right, is this one here, where we basically use the -1 approach. That'll just find the last position automatically. I don't have to run a function or a method, excuse me, to probe for the length. I don't have to know in advance the size. None of that. This will just work. So out of all of these, I'm going to mark this one, recommended. That's the approach you should use. So let's run this and see if indeed that it does work. So all of them got the correct first and last items, but you have to admit the bottom one is the easiest syntax, right? Yeah, that's like definitely the easiest syntax, and that's why I recommend it. All right, folks, we are going to pause the video here and we are going to take a 5-minute break or so. Let's come back at like 9:01. All right, folks, I did forget to save before. So I did go ahead and save my file using my conventions here. Let's go to the next exercise, which is exercise 6.2. And this one says, write a program that reads numbers, meaning we're going to prompt the user for them, right? Or actually, does it really imply that? Reads numbers and adds them to a list if they aren't already contained in. Okay, so this is kind of an interesting thought. When the list contains 10 numbers, the program displays the contents and quits. Okay, now I captured that, and so I have that here ready to drop in. I've copied that little instruction. I'm going to go ahead and make a new program, but it just dawned on me. I wanted to demonstrate something in the other program. And so let me save this right away before I forget, right? Or before you catch me on it. So I'm going to do a save as, and I'm going to save it as EX exercise 6_2. Okay. Let me go back to that previous program though. I wanted to display, like we made this run up to a number of 10 integers, right? But what if, right? And I'm just throwing it out there. What if you wanted to do 50, for example? And so I'm going to run it now with 50. Notice how very quickly it generates a list of 50 random numbers. It becomes a little bit harder to look at and process mentally, but notice that all the algorithms still work. The even position numbers, 67, 58, 8, all the numbers that are even, that's a really easy one to see. In reverse order, 34, 65, etc. First and last items, all the algorithms still work. What if I wanted to make it 500, right? And just to show you how quickly Python scales up, and notice how quick that was, like almost instantaneous. And yeah, you can create some pretty large data sets with this very easily. Now think about this. Why do we use the random number generator? Because if I had to type all that out manually, man, that would be a pain. Right. That's the one reason why. Plus, it allows us to really have random values to work with. So, I mean, the example is set to 10. So I'm going to set this back to 10 and then save it. But I think the demonstration is pretty evident in and of itself. All right, let's try doing this now. So let's start by creating a bunch of blank lines. And let's read the instructions one more time. It says, write a program that reads numbers and adds them to a list if they aren't already contained in the list. When the list contains 10 numbers, the program displays the contents and quits. Okay. So we are going to prompt the user for numbers. I typed in this little comment here the last time I did this. So build a list of 10 unique values. You don't have to do that part. Kind of the same thing that we did before is I'm going to set a variable that's going to control the number of numbers, right? Because we don't want to go beyond it, but if we did want to change it later, we could easily adjust this one number. And I think I called it last time. Oh, I'm typing in the chat. That's not where I want to type. Oops. Let's type over here. I called it num of nums, number of nums, right? And I'm going to hard code that to 10. Um, but we can try different values later after we do it with 10. Right? We just change that number and the whole program will scale. So that's kind of fun to do. Once again, this isn't a necessary step, but I'm just doing it. Right. Here's the next little comment I threw in: read a collection of values from the user, adding each to the list if it's not already present. All right, well, let's create a list. Can we just use the same name? Are you guys okay with that? Let's just call it values. Fine. We can call it chopped liver if you wish. It doesn't really matter. Last time we used for loops, but this time I'm going to use a while loop, and here's the why. The while loop runs off of Boolean logic. So I can trigger it to stop once we've entered the number of numbers that we need, right? So just listen to what I just said. So I will run the loop while the length of values. Now I want you to think about this. The length of values will be what? Well, 10, right? But the index positions will go from 0 to 9. While that is less than the number of nums, the loop will execute. So it'll never reach 10, right? Which is what we want, right? So that length value will never reach 10, but we have to increment that every time we run the loop as well. So let's kind of do this first. Inside the while loop, so now the while loop is running, we're going to prompt our user for input. I'm going to say, let's make it a floating point number, and then we'll put in our input statement inside the conversion. And I'm just going to say, enter a number. Now, do I really have to make it floating point? No, it could be an integer if you wish. You could argue either way that a number is a number. I just decided to make it a floating point. So they're going to type a number, right? And here's what we're going to do. Notice the instruction here. It said, and it adds them to the list if they aren't already contained in the list. So if I type the number 1 and then type the number 1 again, it's not going to let me enter it. It'll still accept the number, but I'm going to have to keep typing to let it go. So how do I test that? So I'm going to say if X, the number that we just captured, is not in values. Weird statement. So I can check. I could check if it is in values, or I could check if it's not in values. So if it's not in values, then I will append it. Otherwise, I won't. So I'm just going to say values dot append. And then what position is it going into? Or what am I appending to the list? Not position. What am I appending to the list? Well, whatever the number is. Okay. And really, maybe truly, I should make this all, think about this. I could make this all integers. That would be fine too. Or I can make it all strings. It doesn't really matter what we're adding to the list. So you could play with any of those. So maybe a good note to put here is could be int, could be string, right? Or whatever you want to capture can go in here. It would work. Right. So this would capture it. And then why is this flagging like this? I know why. Because I didn't put double quotes around my prompt. It's always the little things that get you, by the way. All right. Is there anything else I need in my loop? No, not at all. This will keep prompting and it'll keep running why don't I need to add like a length or something? I don't need to do that. And here's why. Because the length will change. Every time I append a value, this length will change. And so as long as I get 10 unique values in there, it will eventually reach 9 and then eventually reach 10 and stop operating. Right. All right. Now, if we want to display the output, here's the output. Oops, that's not the output. Let's try that again. I'm gonna hit copy over here. So we're just going to do a simple print statement. We'll put the list in there and we'll see it. Right. So this is the whole exercise right here, folks. Really, really simple. There's some logic pieces in here though that are kind of useful. Let's run this and let me show you an example here. So I'm going to do like some floating point numbers, some regular numbers. I'm going to repeat a number a few times. Let's try a different number. Let's try some bigger numbers, some weirder numbers. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should be it, right? Nope, because 3 of those repeat. So I'm going to have to come up with 3 other unique values. And I think we're probably at that point. There we go. So finally got 10 unique values. It's put them back on the screen for me. And notice none of them repeated, even though I did repeat them up here. Once again, you can do this with integers if you prefer. You want to try it with strings, that's absolutely fine. Now, we haven't played with tuples at all, and none of these exercises really focus on tuples. So I did want to do a little bit of thing where I kind of demonstrate, for example, if I set up values 2, right, and I create a tuple in advance, which is hard coded, right? And this is not when I can prompt a user to enter. Why? Because it's immutable. They can't enter information into it. I have to pre-create this. Right. So I can just pre-create a tuple and then I can output that tuple like this. This is one way to output it. So I'm just going to run this. Of course, I do need to type numbers in again. So let me do that. Why is it not letting me finish? Because I'm putting in repeat values. Right, there we go. But it did convert them all. And then notice the tuple does function, right? And, if I wanted, for example, I don't know how that got there. I know how it got there. Okay. If I wanted, for example, to just print one of the values and values 2, let's say position 4, and right, I want square brackets there. I just use that command. Once again, I'll have to re-enter all the numbers, so there you go. So you can play with it. And this is very much, let's mark this down here as, and I'm not really sure why I had it in there. Let's call this optional fun with tuples, just so you get to touch it a little bit. All right, let's save this one, and now let's move on to that last exercise. That last exercise is a multi-parter, so it's going to take us a little bit longer. This is exercise 6.4. Let's create a new one and do a save as right away. We do have plenty of time to get it done, by the way. Exercise 6_4. Let's go look at the directions on this one. And wow, there's a lot of directions, right? So you can see why I'm saving a good chunk of time here at the end. Now, notice this has a lot of stuff in it, and it says write list functions. We got to create functions for each one of these that carry out the following task for a list of integers. For each function, provide a test program, right? And we're going to run them all from the same program. In fact, what I'm going to do here is I'm going to use the main method approach. So I'm going to create some data structures. I'm going to create a main method. I'm going to create functions for each one of these letters. And then I'm going to call them all from the main function. So this is going to be a fairly long program that we're about to code here. If it helps you to move all these instructions over to your document, do it. What I did last time is I just moved them incrementally one at a time. And notice, I want you to read the instruction at the beginning. That's just really important. It says, write a list of functions to carry out the following task for a list of integers. And what I'm going to do is I'm just going to pre-create some really basic integers, like maybe a list of 1 through 10 or something like that, and then just kind of work with those. That's kind of my goal. So let's do that first. And I want you to notice here, define a list of numbers as a constant, right? It could be a tuple, right? And, I'm going to say that this word, we don't really need it as a constant. The whole point is we're not going to really necessarily change the information in them, but we know that a list can change, but a tuple might not, right? So I'm going to start with one basic list for now, and I'm kind of boring with this kind of stuff. So I'm going to be really predictable, and I'm going to create a list called 1_10, which is a list of the numbers 1 through 10. And we're going to use that originally to test things. I thought it would also be fun to work with a tuple, to show you that all of these functions could possibly work with a tuple. Some might not. Right? If I'm just putting stuff on the screen, a tuple will work great. If I'm trying to like I was looking at like one of these swap the first and last elements, well, I can't do that with a tuple. That just won't be allowed. But you know what? Let's just create a structure called with tuple like that, right? And then we'll basically just make a tuple with the same numbers just to show you that it works. And then I might add a couple of other data structures here too. But for right now, I'm putting all my data structures at the top. I'm making them global to the program, meaning all the functions in the program can access them. Now I'm going to define my main method. So here's my main method. I'm going to type in a pass statement, remember? Right, so nothing operates in there yet. And then way down here at the bottom somewhere, I'm going to call main to run. If you wanted to use that more complicated if statement where it's like if double underscore name double underscore equals main, blah, 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 you can do that too. I don't think that's necessary here. This is pretty simplistic. Okay. So let's start out in the main method here, right? And then notice what the other thing I'm going to do that's going to be kind of weird is I'm going to put in like a little divider, right? And I'm just going to say functions below, something like that. So the first thing I thought might be helpful, right? And think about this is since we're going to like run the code and we want to see, like, we don't really always know what the numbers are going to be. I think it's not a bad idea to just display the original list of numbers and tuples for that matter, right? And we'll just do some simple output, right? So here's how I did mine. I'll copy the one statement here and paste it in. So this is inside the main method. So I'm going to print the original list, 110, right? I'm going to paste that in again. And then here I'm going to call with tuple, right? With tuple, yes. All right, let's run it, make sure we're good. All right, original list, original tuple. Notice the output on the tuple with parentheses. All right, so that works. I'm going to add a blank line in here. And let's go to the first function, which is called swap the first and last elements in the list. So I'm just going to, I have that copied here. So I'm going to just put a little title here, right? And then in my head, I'm saying to myself, well, that means I'm going to write a function called swap first last. That's what I'm going to call mine. So I'm going to come down here and I'm going to start defining my function. So the first one I'm going to call swap first last parentheses and a colon. And now I got to think about what the heck I'm putting in here, right? All right, let's go back up to the main program body. I'm going to put a pass statement here for just a moment. And then I'm going to think about how I'm going to like call it and run it. All right, so here's one little issue that we might have. We know that a list is mutable. That means I can change its contents. So if I take my original list and I run it through swap first last, it's going to change the order. And then I won't be able to use that order for my other functions, right? So I'm going to make a copy of the list. Right. So so this is kind of going to reinforce that like a copy by reference and a copy by converting something to a list. So I could do this, and this is really weird. I could just say data equals 1_10. So that would like, it looks like, okay, well, you got like one list, you're copying it into another list, right? And this is a really weird thing. And I have this in the lecture notes, and I'm trying to see if I can get to the back to the web page here for our course. Okay, so I'm going to focus on this for a second. And this is a really weird feature of Python, right? It's kind of heady in a sense. It says you cannot copy a list by just using list2 equals list1, right? So think about this. If I set up a list1, put in the letters ABC, and then copy list1 into a new thing called list2, what happens is it creates a reference to the same spot in memory, right? So if I change position 0 in list2 to a Z, so it's no longer an A, then if I output both of them, both lists have changed. So that's really weird, right? So I can circumvent this two ways. I can either run the list copy function to create a new list, or I can create a copy of the list by running it inside the list constructor. And I do explain all this in the lecture materials. And so I'm going to do it right now in the code. Basically, I'm going to use one of the two approaches. So I don't want to do this because this would copy it by reference, right? Which is what I don't want to do. And I might even say this would point to the same list, right? So not good generally, especially if I change it. So I'm not going to use that approach, right? There's times when you might want to actually do that, but I'm just saying, right? So you don't have to copy that code. Really, the best approach, I think, the one that I usually use, is I usually use the list constructor, and then I'm going to take the existing list, which is called 1_10, basically run the list constructor on it and store it in a list called data. And then when I'm ready, I can send it to my function, which is swap first last. What am I sending to it? The copy I just made called data. Okay. And then we're going to want to look at the output of it. So yeah, I know I haven't made the function yet, but I can still engineer the other parts of it. So I'm going to do f string, and then I'm going to say after swapping first and last. And then I'm just going to output data and we'll see if it worked, basically. All right, so there's my commit. So in the main program body, I've made a copy of the list using the list function. I'm going to run the first and last thing by sending my list to it. And then I'm going to put it back up on the screen with a message so I can see that it actually worked. Right? Yes. Okay, good. All right. So now we got to think about the maneuvers it takes to swap the first and the last thing in a list. Okay. So how about this? How about I set up a variable called last, and in there, I can pull the data from the last position. How do I indicate the last position? All right, this is like a repeat quiz. -1, right? That gives us right to the last position. Or I could say length data -1. That would work. You know, all those techniques that we did before. But -1 is really the quick and easy way to do it. So you should get comfortable with that. And I'm looking not at the right piece of information here. So I'm gonna strike this, right? Because I'm looking at the next function. So I apologize. All right. I'm going to backtrack here. So I apologize for kind of confusing the waters there for a moment. Let's look at the lists for a second. And I want you to think about this. Like if these were books on a shelf and the shelf was tightly packed with books, so there's no room to put any more in or out, and I wanted to swap the first and the last book, how do I do that? Well, I could go to the first book, pull it off the shelf. For a second, I got to hold it temporarily. Then I can go to the last position, pull that book out, move it to the first position, and the one I'm temporarily holding from the first position can then go to the last. Right? I can't just like, whoosh, I can't do that. Right? I gotta have to have a temporary spot to hold it. So here's how I would do it. I would create a temp variable. I would take the data from the first position and put it there for a second. Then in the first position, I'll grab the data from the last position and copy it in. So I'm going to go to data -1. So what was in the last position is now in the first. Now I got to take that stuff out of the temp position and put it in the last position. So the data in the last position, the -1 position, will now get the data that's in temp. So we're doing the old switcheroo here. I'm getting a whole bunch of errors, and let's see why. Undefined name data. Oh, yeah, right. Because when I sent in my list, I never passed in the parameter. So I got to send my list to the function. That's why it was yelling at me. So here's going to be an example of a complex data structure being passed to a function. It reads it in, takes the first position out, puts it in a temporary holder, grab the last thing, put it in the first spot, take the temporary thing and put it in the last spot, and then we're done. And then we'll print it and see if it worked. All right, try it. Yeah, let's try it. Here's the run. All right, original list, original tuple. And really here we should say tuple. All right, after swapping the first and last, 10's in the first position, 1's in the last position. So we're okay. All right, let's move on to the next task. All right, the next task, I'm going to try to find it in my code here, so I apologize. I'm kind of fumbling between screens. Okay, the next task is this one. I'll just drop it right into the main method up here, right, as a form of a comment. And the instruction is shift all the elements by 1 to the right and move the last element into the first position. So basically, we would like take this and put it there, take this and put it there, etc. And then when we get to the end, this will come back to the beginning, right? But that's what we're doing. Move everything one over. Now think about how this would have to happen, right? And I think this is like, kind of one of the fun things about programming and thinking about how you solve the problem. Sometimes using like a physical analogy is really smart. So go back to the bookshelf example, right? Well, if it was a bookshelf, I would pull out the last book, put my hand in, slide all the books over, and then put the one in the 10 or the 10 spot in the one spot, right? And then I'm done. Think about it, right? That would be kind of how I would do it in physical sense. But we're still having to move all the books, whether or not you're picking that up or not. So we would have to figure out then um, how to do that code wise. So this is really kind of an interesting little example. Now, once again, before I code the function, right, I'm going to kind of set myself up to run the function first. So here in the main method, I am once again going to take my data list, right, and I'm going to create, and we can do it a different way. We can do the other approach, which is the list copy approach. Let's try that one, right? So I'm going to do that instead. So I'm going to do list dot copy, and then I'm going to put in 110 here. So we're going to take the original list, we're going to make a copy of it and store it in data. And I'm going to put a little note here, alt way to copy a list, like just for reference, just to demonstrate it. I do tend to do this one more, I guess, than I do this one. All right. The next thing that we would do is we would call it to run. And I haven't even made the function name yet. I'm thinking that what might be a good name is shift right. Shift everything to the right. What am I shifting? My list called data. And then, of course, I'm going to output it to the screen. And I'm just going to say a statement like print f string after shifting right. Maybe that's enough right there. And then we will display data on the screen and we'll see the results. Okay. Now notice here, I'm calling a function that doesn't yet exist. So what is it doing? Undefined name shift right, right? Okay, so here's my little commentary. If I was working in a more advanced editor, right, and I'm thinking to myself, I was working in like Visual Studio Code, perhaps, or maybe I was working in PyCharm or Visual Studio or one of those higher end tools. If I created a function name like this and it didn't exist, I could do a right click and it would just create the function for me, right, automatically. This tool doesn't have that. At least I'm not aware of it having that. So let's define it. I already gave it a name, right? So I'm going to define shift right. And I'm going to just drop it in here with the call with the data. That's fine. And then we'll start writing some code. All right. I don't know. I have this habit of putting the pass statement, and you can tell because sometimes create a bunch of them and then start to write the code. All right, let's think about the maneuvers here. Okay. Think about the analogy that I just made with, all right, if it was a bookshelf, how would I do it? I'd pull out the last book, put my hand in there and slide all the other ones over. But notice that last book, where's that last book? It's in a temporary spot for the moment. And then eventually, after I slide the other ones over, I got to put it back. So we got that same temporary situation going on. But instead of calling it temporary, I will call it last because that's where it came from. And then I'm just going to extract the data from the last position. There's the -1 thing again. So I pulled out the last book. Now I'm ready to start shifting everything over. Now, on a bookshelf, in principle, I could stick my hand in and push all the books at once. It's problem solved, right? In reality, the way that would work, I want you to think about this, is how would I start shifting? I just made a copy of the thing in the last position. So the logical book to move first is the second last one. and then the third last one, etc. So I'd go one at a time backwards through the numbers in a descending order. I can use a for loop with a negative range command traversal, right? Not even sure if that's like the right way to say it. So I'm going to say for I in range, and if you remember how we did this in the previous thing, I could take, and I'm just going to use one of the approaches here just for the sake of it. I could take the length of data, which is what, 10, right? That's not the last position though, so I have to subtract 1 from it, right? So the length of data minus 1. I'm going to be counting down to what position? Not to 0, right? Like remember when in the previous example when I was targeting 0, I had to go to minus 1 to get there. But I don't need to do that because that last we're only going down to position 1, right? Because position 0 is going to shift over. So I would have it go to 0 to get to position 1. Right? There's a little bit of a mind bender to get used to the syntax. And then we're counting down by 1. All right. From there, we just need to do the maneuvers. So think of the maneuvers. Whatever's in the current position is going to be shifted. And mind you, we're going backwards, right? To do this, we're going to grab the current position minus 1 and put it in the current position. So that looks like this. So data in the current position is going to come from the current position. So it would be I minus 1, like that. So, and it's just going to continue. This is a weird one. And if this one's a kind of hard one to understand, what I think really helps, like, and if this is how your brain works, and I'll tell you what, when I was first doing loops and doing stuff like this, I would often have to draw, you know. So here's what we're doing. We're going to take that number out, and it's going to go in a temporary spot called last, right? Then what's our current position? Remember, we're counting backwards from 9. So the first one's pulled out, then we're counting backwards from 9. So we're at position 8, right? Length of data minus 1. Well, length of data is 10. No, we're at position 9. We're at position 9. Now we're going to take this, right, from that position and put it in the current position. So we're going to take this, which is, this is the I minus 1, and then that's going to go here, right? I know this is really weird, but these, I mean, we're mechanically moving each piece to a different spot, right? So I'll clear all the little drawings here. Maybe that'll help a little bit. All right. When the loop is done running, we still got that one that we pulled out of the last position. That's got to go into position 0. So here's that first position will be populated by whatever was in the last position. And I called it last, so you could have called it temp or, you know, whatever you want. Right. Let's go ahead and run it. See if it worked. All right, so here's the run. All right, so after swapping first and last, after shifting right, and notice everything was moved and now the 10's at the beginning. Kind of weird, right? But there it is. All right, let's move on to the next directive. And we are rapidly running out of time. So I'm going to start moving just a little bit faster. And I will say just in advance, I think I'm not going to hit the 9:50 mark. So we might go like 5-10 minutes over. If you guys can hang, that's great. If not, I'm going to be recording. All right, the next directive is this one. Replace all even elements with 0. Okay, let's start by making a copy of our list again. This one I'm going to call replace even. And then I'm going to, since I'm going to call my function that, I'm just going to copy that right now. And then we're going to output it to the screen. Here's the print statement for that. all ready to go. Now I just need to make that function. So here comes the definition. I'm going to paste, oops, yep, I want to paste in this. There's my colon. And now I got to think of the mechanics of this one. All right. So in this situation, I'm going to go from position 0 to the last position, right? Every time I step through a position, I'm going to do the mod 2, look for a remainder of 0. And then if that is even, I'm going to replace it with the number 0, right? So follow along here. I'm going to start with a loop on this one. So I'm going to say for I in range, I'm going to start at 0, and then I'm going to go to the length of data. We're never going to reach it, by the way. Okay, question. Could I put a -1 in here? I don't know. Let's test it. But here, I'm actually going to go to the length of data -1. But could we go to the last position that way? I would challenge you to test it and see. And actually, I don't need the -1 here. Then I'm not thinking clearly on this. Stop for a second and think about this. I'm going from position 0 to the length. It'll never reach the length, and that'll be the last position. Okay, so that is the right command. So sometimes you have to think it through and talk it out, by the way. So if the data in the current position, that's, and not curly brackets, square brackets, folks, shift by mistake, mod 2, when that's equivalent to 0, another colon here, then we're going to take the data in the current position and set it equal to 0. Right, that's the whole command. It is throwing, oh, I wanted to do mod, not $sign. There we go. No wonder it's throwing an error. All right, running it. All right, so 2, 4, 6, 8, and 10 were all replaced with zeros. All right, let's keep moving along. We got 3 more functions to write and 7 minutes of time. It's not a lot of time, but we'll get there. So, all right, next directive is replace each element except the first and the last by the larger of its 2 neighbors. Uh-oh. All right, so think about how this is going to work, right? So look at one of our list of numbers. So we're not worried about the first, we're not worried about the last, but when we get here, I want to replace this with the larger of its 2 neighbors. So it's going to look here, it's going to look there, and then it's going to put 3 here. Then it's going to go to this one, and it's going to look at 3 and 4 and move the 4 here. Do you guys see what's going to happen here? All those numbers are going to get shifted. All right, so this will be kind of an interesting one to write also. Once again, we'll make a copy of our list. We'll call this function replace neighbors. I still have to create it, but I'm going to keep that in memory. And then I'm going to just have a print statement that says something to the effect of after replacing with neighbors, or whatever you want to call it. Right, what are we going to put in there? Data. Let's go make that function. Making a little space down here. So here's defining it, putting in our colon, and then let's write the code for it. This one's going to run on a loop too. And in the interest of time, I'm just going to start copy pasting in just so we can get done in time. So I'm going to set up another for loop here. And from here, we're going to start at position 1. Why? Because we were told to ignore the first thing. And then we're not going to run all the way to the end. Otherwise, length of data would work because it would fall 1 short. We want to go 1 less than that. So we're going from range 1 to length of data -1. All right. So for each time we go through, we're going to assign to the current position whatever's bigger, and then check out this really clever use of the max function, right? Well, I'm looking at the current position minus one to the left, and the current position plus one to the right. It's going to find the biggest one, and that biggest one is going to go in the current position. We've already kind of worked through the mechanics of it. So the mechanics are basically most of the bigger numbers on the right are going to shift over to the left. The first and the last will be untouched. All right, let's go ahead and run this. It is ready to run. After replacing with neighbors, see how all of these shifted. And then, so 2 through 9 became 3 through 10. First and last were left alone. All right. Next directive is kind of a weird one also. Here's the directive. Remove the middle element if the list length is odd, or the middle two elements if the length is even. Okay, so here we got a problem. I've been using the same list all along, and that's got an even number of elements, right? What if I create another list that has an odd number of elements, and then I'll test with that one too. So I created another list, and I'll share that with you so you guys don't have to type it. Called 1 through 9, and it goes from 1 to 9, right? And that's an odd number of elements. So when I run this one, I'm going to need to make copies of two lists, both of those, and then send both of those in, and then look at both of those in the aftermath. So the way I did that last time, and yes, I'm copy pasting for speed here, right? Just so we kind of finish in time, is I did it like this. So I created a data 1 and a data 2. One copies 1 through 10, one copies 1 through 9. Then I called my function, which I haven't named yet, by the way. But I'm going to copy that so I can create it. And then I printed in the aftermath using the old parameter or argument approach, both of the data sets. Right. I'm going to come down here and define my function. And then inside here, I'm actually going to call it data, not data 1. Right. I want a more generic name so it can receive any list. And then we'll build the code from that. We're calling this one remove middle. So this is kind of an interesting little conundrum. If I want to remove something from a list, because we haven't done that yet, we've just been moving stuff around, right? How do I remove something? Well, there's a command called pop. I want you to think about this. If the list has an odd number, right, and let's kind of ration through this a little bit, like 1 through 9, how do I get to this position? That's the middle one. That's 0, 1, 2, 3, position 4. So how would I get position 4 as a number to determine that? Well, I think I would have to write an if statement. So here's how I would handle it, right? And there are other ways to do this too, but this is what the method that I came up with. So I'm checking the length of my data, right? And I want to see if it's odd or even. And I'm going to take that length. So in this case, the length is 9. I'm going to mod it, mod, times the charm, by 2. And if the remainder is 1, then it's odd length, right? And in that case, I can remove a certain position. Now I know the length of it, so I could just hard code the number in here, but that's not going to work. How can I mathematically do this? Well, here's kind of a clever trick. I'm going to take the length of data, whatever that happens to be, and in this case, the length is 9. And instead of dividing, I'm going to do integer division, a double forward slash, and divide by 2. And I want you to think about how this works. If I come over here to the prompt and I do 9 divide by 2, what does that give me? Position 4. That's what we're looking for. But this is integer division, right? This is division that only shows me the non-remainder answer. So that works. That puts me in the right position. So this logic actually will pop it up right there. All right. But otherwise, it's going to be even, right? The list is going to be even in length. And how do I deal with that? Well, I kind of do the same thing. So, but there's a different approach. If I do the same math, right? Here I have 10 positions and I want to remove, it says the middle two elements. So if I come in here, run that same function, but it's 10 divided by 2, what's the output? 5, right? Because it'll go in there evenly. So it would come in here and pull out the 6. Then all of a sudden the 6 is gone, and then it's down to a list of 9. And we know the math for that one takes us to position 4, which puts us here, and then it would get rid of the 5, but not in the order we thought. So I could basically run that same exact command 2 more times like this, and that would do it. This is really kind of like, might take a little bit of logic to figure this one out. Like if you were coding it on your own, you might, frankly, you might not ever get there. But notice here, here's the 1 through 9 with the 5 missing. Here's the 1 through 10 with the 5 and the 6 missing. All right. One last one to complete, folks, and then we're going to call it a night. Okay, so here's the last directive. So move all the even elements to the front, otherwise preserving the order of the elements. Whew, that sounds like a challenging one, right? And it is kind of like your brain starts thinking about it. Let's start with the basics. Make a copy of the list. Again, I'm going to call this one even to the front. I still have to build it, right? And then I'm going to put the results on the screen like so. And now we have to build this one even to the front. I'm coming down here, defining a new function. Got to put in the def here, put in a colon over here. And then we start to do our maneuvers. This one is a little bit weird, right? Because we got to track 2 things here, right? So if I'm going to like check a value and then determine if it's even or odd, that's one thing I'm going to have to do. But I also have to loop through the content. So I have to loop and check for even. And then if it's even, I'm going to pop it out, remove it, but I'm going to store it. So this is kind of interesting. I can pop out a value, and the value that I'm popping, I can put in a variable. So I'm going to hold on to that. And then I'm going to do an insert command to put it into a position, which I'm going to track every time I go through. And if it hits on the if statement, I will increment it. Otherwise, I will increment. Okay, so I need a couple of counters, I guess, is what I'm coming up with. So here's my counters. So inside the function, I'm going to have a position counter and an even position counter. I'm going to start them both at 0. Then I'm going to go into a while loop. The while loop's going to run like this. While the position is less than the length of the data, we will go through. So the position will go from 0, basically, up to 9. So it'll never reach the length of the data, which is 10. Okay. Every time I go through the loop, I'm going to run this if statement. Basically check to see if the data in that position is positive, right? So this is something we've done before. So we're going to position first, we'll check as position 0, right? Mod by 2, if it's 0, then we'll do our maneuvers. So here's the maneuvers. I set up a variable called temp, and then I'm going to pop the data. So I'm going to say here, data.pop in the current position. This will remove it from the list. But in the process of popping it, I'm also storing it. This is really kind of a neat feature, right? That we can do that. So I did the maneuver. And now I want to take that data and insert it into a spot. Now, the way the insert command works is I choose a position. Right now, the first time through, this will be at position 0 for the even position. And then what am I inserting? The data in temp. Now, the insert command is kind of an interesting one. When I insert at a certain position, so at position 0, whatever's there currently is going to get pushed over to the right, like the bookshelf, and then the new data will go in that position. So it's inserting a piece of information in that spot, but it's also taking all the other information and shifting it. So that's what the insert command does. And then, since I put something in the even position, I'm going to increment the even position counter by 1, like so. Then the if statement's done. And since the if statement's done and the loop is still running, then I'm going to increment my regular position by 1. So now I'm going to look at the second position. And this is more like a classic while loop kind of thing, because we're traversing a structure, but we have to know to increment the counter to get us through the structure, right? If I forget this, we'd be in an infinite loop, which is not good. All right, that's all the code for that function, by the way. I'm going to go ahead and run it, and then we'll call it a night. Here we go. Here's the run. Notice all the even ones are at the beginning of the list, and then all the odd numbers had like even numbers inserted in front of them and pushed over to the side. Now, if your brain is saying, hey, when we did the shift right thing, could we have done that? Could have done it that way? Yeah, we could have done it that way. The insert command's kind of a weird one, because like if I insert something at position 0, once again, whatever was there now becomes position 1. So like if I drop something here, all the rest of it moves over. All right, folks, that is the solution for exercise 6.4. I do plan on releasing an extra credit assignment. I still got to tweak the wording on it a little bit, but I'll put it out there. I might even record a solution for it. But this video ends here, and I'll see you guys next time.